Hello everyone, this is Huaxiu from Stanford. Today I will present our wild time benchmark for modeling in the wild temporal distribution shift over time. Temporal distribution shift is a kind of distribution shift that arises from the passage of time, which is also widely accessed in various applications. For example, to predict flu incidence from search queries, we train a model from 2004 to 2007 and then evaluate it on 2008. We can get very impressive performance compared to the ground truth CDC data. However, deploying the same model to 2013 produce double the instance, indicates the distribution shift. Another example for gender prediction is illustrated in the right-hand side, where we use portraits to predict the gender. We train a model from 1930s to 1960s and then deploy it to 2000s to 2010s. The large performance job also indicates the temporal distribution shift. Prior continuous learning benchmarks face two key challenges. First, most of these datasets are not focused on natural temporal distribution shift, and which are manually create distribution shift between consecutive time steps. Like this example here, the authors create distribution shift by changing the objects for recognition over time. Second, in some real-world dataset, we cannot observe apparent temporal distribution gaps between in-distribution and auto-distribution performance. For example, in CLEAR benchmark, we train the model from 2004 to 2009 and then deploy it on data from 2010 and 2014. However, we only observe slightly performance jobs around 2% here, which may not be caused by the distribution shift over in some cases. Based on this, we propose two criteria for selecting dataset in wild time. First, we aim to pick datasets with temporal distribution shift and show clear performance jobs. For example, we exclude the CLEAR benchmark since it does not have clear performance jobs. And we select the yearbook dataset to predict gender since temporal distribution shift happens there. Second, we only focus on gradual temporal distribution shift. Since models can more effectively extrapolate temporal correlations when the distribution shifts occur gradually over time compared to the sudden distribution shift. For example, we pick the mimic motility task when the performance gaps between ID and OOD increases over the test time steps. While we discard the drug BA dataset because the in-distribution and auto-distribution performance gaps is that large, even for the first evaluation time step in 2017. Based on these two criteria, we propose wild time, a benchmark of 5 datasets and 6 tasks. First, in yearbook, we use portrait pictures to predict the gender ranging from 1930 to 2017. FMW predict land use with the satellite images covering example from 2002 to 2017. Mimic 4 has two tasks using diagnosis and treatment to predict readmission and mortality rate, including examples in 11 years. The last two datasets are text classification datasets capturing the range of factual knowledge. First, HuffPost use article headlines to predict news text. Archive used paper titles to predict its preliminary categories. We further propose two evaluation strategies to evaluate the baselines. First, we propose evil fix. In evil fix, we find one fixed time step and train the model before the selected time step, and finally evaluate it on the time steps after the fixed one. Second, we propose evil stream, which provides a more realistic evaluation setting for real-world streaming applications. Here, the model is trained incrementally at each time step and evaluated on the next while. In our experiments, we first observe clear performance gaps between ID and OOD performance on every dataset. Second, we show the per time step performance on evil fix. Please refer to our paper for the results under the evil stream setting. Here, we basically observe that most continuous learning and environment learning approaches do not show substantial improvements compared to ERM and fine-tuning. So we hope that wild time will accelerate the development of temporal robust models. Finally, to make wild time easier to use, We provide some simple APIs and release a Python package that automates the data loading and baseline evaluation. All informations about code paper are released in our website. Thanks for listening.